Exponential equations can come in a variety of different forms. Our focus is going to be primarily on those equations where the base is the same on both sides of the equation. And in the event that the base is not the same on both sides of the equation, we'll have to use a little bit of algebraic manipulation and a few rewrites using the exponent rules to make those bases the same. So we'll look through in this video a few of the more basic examples, and then in the next video we'll look at some of the more challenging ones. So let's start with a really simple equation. 5 to the x is equal to 125. So obviously at this point you should clock that 125 is one of the powers of 5, namely that 125 is 5 to the power of 3. With that understanding, we can rewrite this equation as 5 to the x equals 5 to the third. And it doesn't take someone in an Algebra II class to realize that all we need is those exponents to be the same. So we get that the value of x is 3. That ability to rewrite one of the sides of the equation with the same base, not necessarily the same power, because that's where the equation is going to come in, but the same base, is going to prove critical to our solving these equations. Let's look at another. 3 to the power of 1 minus x, already more complicated than the last example, is equal to 1 over 27. You should be looking for multiple opportunities to try to match these bases up. So you should check that the number is a power of 3. Well, 1 over 27 isn't necessarily a power of 3, but I know that 27 is a power of 3. But because that 27 is in the denominator, I need to reflect that somehow in this expression. I can't just write this. This isn't going to work. So I need that 27 to actually appear in the denominator if I was to evaluate this left-hand side. That's where negative exponents come in. So in the event that you're given a question that has a reciprocal in it, remember the power that a negative exponent has in turning something into a reciprocal. Same deal again. In order for these to be the same, the exponents have to be the same. So we write a new equation that says 1 minus x is equal to negative 3. Subtract 1, divide by negative 1, and we get that x has to be 4. You can always back check your answers and make sure that they actually work, which in this case it will. 6 to the power of x minus 3 over 4 is equal to the square root of 6. Again, we look for the right-hand side base to match the left-hand side base. And in order to do that, we need to do a quick rewrite of that square root of 6, reminding ourselves what the square root power actually means. The square root actually means a 1/2 power. So we can rewrite our equation as x minus 3 over 4 is equal to 6 to the 1/2. And we know that those two powers will have to be the same. Whichever strategy you want to solve to use this, I prefer the multiplying by the common denominator to clear out the fractions. That leaves me with x minus 3 is equal to 2. Therefore, x is equal to 5. Substituting that back in, this power becomes 2 over 4, which is the same as a 1/2, and those are equal to one another. So again, making the bases the same. In this last example, it's not immediately obvious how to make the bases the same. 32 is not a power of 4. The powers of 4 go 4, 16, 64. By the third power, we're way past 32. In the event that they cannot be matched through a simple manipulation of one of them, you manipulate both of them. And the key is to recognize the importance of the number 32. 32 is the power of something. It just so happens that that something is not a base 4. It just so happens that that something is a base 2. And if I can rewrite that with a base 2, and I can rewrite the left side also with a base 2, multiplying my powers together, power to a power, setting them equal to one another, and dividing, and getting 5 over 2 as my variable, if I can make them match, even if it doesn't match one of the ones that's already there, if I can just get them to match. And you'll see in every example that you do, the choice of this number will be very purposeful. It's not going to be some number they pull out of thin air in the hopes that you can try to match it. There will be a purposeful choice. If you can't get this one to match that one directly, like we did here, like we were able to jump right to 5 here. If you can't do that, then there's some other smaller base that's going to allow you to do that. And that's the number that you need to look for.